Hello and welcome back. This discussion is supporting the content for week 5 of the class, also known as Session 5. I want to start off with a request. There is a survey that is now available up in the top folder in Blackboard. That's the same one that has the syllabus and the schedule. So I'd ask you to fill out the survey. Again, it's kind of an open-ended thing. As you know, the school no longer does formal surveys around the classes, so this is my way of seeking your input and feedback on what you like about the class or things you'd like to see improved. I will specifically take action on any suggestions you have for the next 4 weeks of the class, and then obviously for future classes. So again, I look forward to and appreciate your feedback. So specifically, the topic today is inventory. As you know from the simulation, the second time around, inventory is a key item. The first time around, there was nothing you could do about the inventory control. I had preset how much material was going to be on hand, how often it was ordered, and the quantities ordered. But in the second simulation, you can change all that. So I thought that a discussion on inventory would be timely. So what is inventory? It depends. Different people have different definitions of inventory. Goldratt says that it's the money that a business has invested in purchasing things it intends to sell. In other words, equipment on the factory floor would not be part of inventory. Pencils and papers in the office supply cabinet are not part of inventory. But then there's a second, broader definition that talks about the stock of anything necessary to do business. In this definition, then it comes down to just about anything you have in stock. So different companies look at inventory different ways. Again, the first definition a little more conservative, the second one a little broader. So it doesn't matter which one you use as long as you know which one you're using and treat your analysis as such. There are different kinds of inventory. Raw material inventory, this is classically the components that go into making an assembly. Work in process inventory, that's the inventory that's in the factory along the way. So somewhere in the process being worked on. So in your simulation, material that's sitting in one of the queues up to the different workstations or in the actual workstation itself would be considered work in process inventory. So that's product that's somewhere on the factory floor, somewhere between start and finish. And then I have finished goods inventory, the third one, and that's product that's done but has yet to be delivered to the customer. So you can define this a little bit differently, but in general, anything in your warehouse waiting to be shipped, and for some companies, items that have been shipped, and then also depends on your partnership with your customer and or any distributors. You might have finished goods inventory sitting at one of your distributors. So for example, if you think about cars sitting on a dealer's lot, those may belong to the dealer, but they may belong to the auto company. So depends on what the agreements are. And then finally, I have MRO inventory, maintenance, repair, and operating inventory. This is material that is not part of the product. This is material that might be spare parts for equipment, might be things like that. So things that are necessary to run the business, but are not necessarily part of the actual finished product that you're creating. Why do I have inventory? To separate parts of the production process. So if I have production, so for example in the simulation you have your little queues between each station. That's separating the parts of the production process. The idea is that you can go in and have inventory, and this inventory is there so that one part of the process isn't starved for product. So for example, if station 1 is running a little slow, station 2 doesn't run out of work to do because of the queue waiting for it. So obviously, once you burn up that queue, use it all up in the production process, it's a different story. But the idea is you can control your inventory, streamline the throughput of your process by managing your inventory in the various steps along the way. Third one is taking advantage of quantity discounts. So for example, one of your suppliers says, hey, I'll give you a deal. If you buy an extra month's worth of widgets from me, I'll give you a discount. Well, you might decide that that discount is of more value than the cost of carrying that inventory. And then finally, a hedge against inflation. So if, for example, inflation or cost changes, something comes up and says, okay, costs are going up, everything else, I might do this ahead of time. or if I know that inflation is going rapidly, I might build up finished goods inventory because it's less expensive for me to create it now than it will be a month from now. So I might get ahead of my business a little bit that way. Inventory costs. Well, inventory costs money. If I have inventory, well, holding costs, the cost of holding or carrying inventory over a set of time. So the whole idea is that if I have inventory, what's going to happen? I've got the stuff sitting there. Well, it's taking up space. I have to pay for that space. I have to pay for the warehouse. I have to pay for the shelves. I have to pay for the material that's sitting there. So my suppliers, they expect to get paid. Then I have my ordering cost. My ordering cost is every time I place an order, there's a finite cost associated with it. The salary of the buyer, the interaction with the vendor. The vendor might have a setup cost charge at their end. And at my end, then I have setup costs internally, the cost to prepare a machine to process an order. So if I have a block of material coming in, the typical scenario is I'd like to minimize my inventory. But if I have setup costs, so for example, if I'm building product A and I need to switch over to product B, well, there's a cost associated with that. So I have to balance that. I might say, well, I might make more product A before I switch over to product B because I don't want to have to go through the setup twice. So I'll build this week's A and next week's A before I build this week's B because I have the time, I keep up, and it eliminates an additional setup charge. So inventory is a balancing act. I have to carry enough inventory to respond quickly and minimize transportation cost. Again, this ties back to my original strategy. Is it more important to respond quickly or to keep my inventory down? The opposite side of it is I want to minimize costs in inventory, facilities, equipment to reduce my warehousing costs. So everything has to be balanced as far as, what are my goals, what is my strategy? Again, how do I tie back to my original strategy? If my original strategy is responsiveness, I may have more inventory on hand so I can respond more quickly. On the other hand, if my original strategy is cost reduction, I may have less inventory on hand because of that. Again, it all ties back to your core strategy. Why is this important? Labor cost. 59% on average of logistic labor is allocated to operating warehouses. In other words, when I'm running around transporting material and everything else, a lot of it is tied to warehouses. A lot of companies, if you have excessive material on hand, you'll see huge warehouses, a lot of lift trucks, a lot of people involved, computer systems to manage all that. And then again, I have carrying costs. Typical inventory is 10.6% of revenue. Annual value of inventory to carry it for a $5 billion company, that's $53 million. So this is a sizable amount of money for a lot of companies. Again, what is your key strategy? Why do I carry that much inventory? Is this just traditional or is it essential for what I'm trying to do? So how do I make these decisions? I have what's called the economic order quantity, or EOQ. What that means is how much and when will I order? So am I going to order 100 parts, 1,000 parts, 2,000 parts? Am I going to do it every time I get below a certain point on a certain date? What is my overall plan? There's some basic assumptions that are key to this, which if you look at these, you'll very quickly see these assumptions don't often hold in the real world. Demand is known, constant, and independent. Yep, we know that's not likely. You saw that in the simulation. You don't know what the demand is. You can create a forecast of it, but it's definitely not known. It's definitely not constant. And lead time is known and constant. Well, you might know that. In the simulation, we've said that the lead time is set and the simulation doesn't change. But in the real world, vendors change. Vendors have shortages. There's a snowstorm, there's a flood, there's a hurricane, what have you. There's a strike on the loading docks, whatever. So lead time is not always constant in the real world. Receipt of inventory is instantaneous and complete, which basically means when the product arrives at my facility, it's instantly and immediately available for use by the factory floor. We know that's not totally true, but it depends. So again, how quickly do I put material in? Places I've worked with in the past, if I had something that was a critical shortage, yeah, we had an expediter waiting at the dock for the material, so it was close to instantaneous. Complete is a different story. I might have an order for 1,000 items from a supplier, and something comes up. They say, hey, guess what? Something's wrong. We'll ship you 900 of them, but we can't get you the last 100 for the week. Well, you might accept that. Or they may not tell you up front. You may open the box and some of the items may have been damaged in shipping, or some of them might be the wrong parts. These things happen. So again, not an accurate assumption for the real world. Quantity discounts are not possible. So again, the EOQ basically says that the cost of a widget today is the same regardless of how much I buy. If I buy 100, the price is the same. If I buy 1,000, the price is the same. If I buy 1,000,000, the price is the same. And we know in the real world that there is some flexibility there and we can get some discounts. And that basically says that the only variable costs are setup and holding, and stockouts can be avoided. And that's kind of the concept here is, I don't want to run out of material. I want to make sure that when my factory needs something, it's available for their use so I can instantly start working on a customer order. So again, the goal is to minimize cost. If I look at the vertical axis, I've got the cost on an annual basis. And it's important to remember it's on an annual basis for a year, because that's the foundation of all of your equations in this case. And then the horizontal axis is your order quantity. How many items do I buy? And what I see as a holding curve cost is a linear curve. So based on my holding cost of keeping something in stock is just linear. If I have 100, it's going to be twice the cost of having 10. So that's essentially the definition of a linear curve. Setup is going to tend to not be linear. The setup or order cost curve, the cost of placing an order each time, of setting up on the factory floor each time, is not. So if I combine these two curves, I get a curve of total cost and setup, which says that I can minimize my cost at the bottom of this curve. So if I look at this curve, there's the bottom portion is where I minimize my cost, and at that point, if I go to my horizontal axis, it gives me my order quantity. So it says that's the number of items I want to purchase based on this cost analysis. And there's your equation. So this number Q is equal to the square root of 2ds divided by h. And you can see this in the book on it's in table 11.5, and there's a lot more detail in the book on the equation. So what's the definition of those elements of the equation? Q is the number of pieces per order. Q star is the EOQ, that's the number you should be buying. Annual demand in units, so if I need 1,000 pieces a year, that would be D. D would be 1,000. Setup cost for each order. Holding or carrying cost per unit per year. So it gives you an idea of all those costs. So I've got that. So when do I order? So again, this equation is how many I order. When do I order? So the reorder point, so we determine the optimum number of items, or in this case we're talking needles, to order. So if D is 1,000 units, again annual, S is $10 per order, H is, or your holding cost, is 50 cents per unit per year, I come up with Q equals 200. So that's how many items I'm supposed to buy. Well, if I look at this, I say, well, if I've got 200 units on an annual basis, that on an annual, or each order, 1,000 units are required on an annual basis. Well, what's the difference? I'm going to place 5 orders per year. So if I take 5 orders per year, how many days are between orders? Well, it's the number of working days per year. Depends on where you're at. Different companies have different numbers for this. If you think about the simplest thing, you might say, well, we work 5 days a week, 52 weeks a year, so I'd have 260 working days per year. But you've got holidays and what have you, so 250 oftentimes is used as an average. So if I say 250 working days per year, I need to place 5 orders. There's 50 days between orders. So the last order I received, that's the next time I order. So reorder point is a situation, is a different thing. So this was how often I order from a time standpoint. Reorder point is how often I order based on the inventory on hand. In other words, we saw in the simulation, if you looked at your inventory charts, the inventory quantities went down, 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 down. And so as they get lower and lower and lower, at some point you can set a trigger that says, hey, when it gets to this point, I'm going to place an order. So the reorder point says, if I take the annual demand in units, the demand per day, And the lead time for a new order in days, that'll tell you my reorder point. So annual demand per day, well, I take my annual demand divided by the total number of working days, which in the previous example we said was 250. So that'll give me how many parts I use per day. And if my lead time is in days, it tells me how many days my reorder point should be. So very quickly, just to go through that again. So my reorder point says what inventory level am I going to stop at and place an order. Again, I'm still using material. So if I think about this, this gets me down, closer to 0. The assumption here is that I don't want to run out of material, but that I'm willing to go right to 0. So let's talk about that. So here's my inventory. We know the real world is not this pretty. So I order a certain amount, and I get down to here and I say, okay, here's my reorder point. This many units. At this point, I'm placing an order. And again, this assumes I'm placing the order right away, and the vendor is receiving it right away and acting on it. Their lead time is L days, so you can see the distance here. So what it says is I'm still using inventory. So I've got to be careful so that my lead time is such that I don't cross this 0 point. I don't run out of material in the warehouse. So this again is the concept. So Q is the quantity, how much I order, and at this point, when I receive the material, this line is going to shoot up like this. And you saw this roughly because, again, this is a theoretical perfect model where I have perfectly linear usage, etc., which doesn't happen in the real world. You saw that in the simulation, that things were a little more erratic, not consistent slope, but it's a good estimate for what you're trying to do. The other thing we talk about here is, I don't have a number down here, but let's talk about that in a second as far as, do I want to actually run down to 0? So here's an example. So I have 250 working days. I want to have 8,000 iPods a year. Lead time is 3 days. I take D, which is the number of working days in a year is 250 down here. I take D, which is 8,000. 8,000 divided by 250 is 32 units. So I'm using 32 units a day. So my reorder point is 32 times 3 days, so it'll be 96. So I have to make sure I have 96 parts in stock, because over 3 days before my next shipment gets there, I'll run out of material. So I'm assuming that everything is perfect. And that's the problem with this. This assumes everything is perfect. My vendor is perfect. My order process is perfect. They're going to deliver when they say they are. The quantity they deliver is going to be accurate. 100% of the material I receive is going to be good quality. There will be no rejects. But that's all the equations. So one thing I wanted you to think about, though, when I look at this, is we don't show it on this graph. But again, I've made all these assumptions in the beginning about how things are linear and everything is smooth and my vendor's perfect and all my material is good. We know in the real world that that's not always the case. So there's going to be some variability. How do I deal with variability? It's very simple. My reorder point, this equation said my reorder point is 96 units. Well, there's a term in the industry called safety stock. And what that means is, instead of running this line down to 0, I'm going to run it down a little bit, maybe to here. So I never get down to 0 according to this equation. So what does that mean? So instead of reorder point being 96 units, I might say if I want to have 10 units of safety stock, I'd change this number to 106. And the whole idea here is that with all this variability that we've talked about, I'm going to keep a little stock on hand just to make sure that things don't, I don't run out. So I might keep a few extra units. How much I keep, that's something you have to decide. You'll learn this over time during the simulation. You'll learn this over time in the real world, that if I have, if I don't want to get below 0 here, I can look back over history and go, well, did I get close to 0? Or did I get below 0? Maybe I put in 10 units of safety stock and see if I ever get below 10. If sometimes I'm below 10 and sometimes I'm above 10, well, maybe 10's a good number. If I'm never below 10, well, maybe I don't need that much. Maybe I can cut it down to 5. Or if I have 10 units of safety stock and I'm still going below 0, maybe I need to increase it. So again, you can analyze data, and using the same mathematical methods that you used for forecasting inbound orders in the past, you can do a forecast of how much my inventory or my safety stock has to be based on how close my inventory levels got to zero. Again, assuming that's your strategy and you never ever ever want to get below zero. So MRP, or Material Requirements Planning. Material Requirements Planning is taking everything we just talked about and putting it on steroids. When we talk about the simulation, you've had a very simple example. Your material consists of one part, one and only part. And so if you think about a car where there are tens of thousands of components, or any kind of machinery, even the simplest assembly, you can have multiple parts. And so you got to manage all that. So, for example, if I have one part that's going to be really, really late, there is no point in having all the other stuff here on time because, it's just going to sit around waiting for the last part. If I'm increasing my volumes, it has to go up. I may have components that are used in multiple assemblies. So if you think about cars coming off the production line, the tires are used on multiple cars. A lot of the parts are. It's in your interest to have as many shared parts as possible, but that requires an additional level of planning. So an MRP system has a lot of pieces to it. Basically, it's data files on the left, the processes associated with it, and then order outputs. Now these output reports, they look like a printed form, but in today's world, in general, they are a display on a screen somewhere. So the data, I have the bill of material, the lead times, inventory data, and purchasing data. So bill of material, that's just simply the list of items that make up the assembly. One of these, two of these, it's the recipe. The lead time consists of where do I do with this? Where are my parts? How long will they take to get here? So for every item in the bill of material, I have a lead time. I have inventory data as far as how many parts I have in raw data, but every single one of those inventory points. So not just raw material in the beginning, but I might have inventory on all of the assemblies in the works, in the work in process, and then all my completed goods, my finished goods inventory, and then purchasing data. Purchasing data is very simple things like how much do I pay to whom for which parts. So I pull this all together, and when I'm done, I come up with these reports. So what's going on by period, by date, order report, purchasing advice, exception reports. So things like, tell my buyers what to buy from whom, when it should be delivered, what price I expect to pay. I can do things like exception reports. So I may have a component that's going to be very, very late. And so I might go to a different vendor at a higher price because they can deliver more quickly and fulfill a need that I might have in my organization. So this is a very complex, this is a simple diagram of it. It actually includes much, much more, because part of what you would include here is like all your order activities going to be loaded in here, all of your people activities. So what's my staffing by job? Do I have people on vacation? Do I have people working overtime? What are my payroll numbers? So again, it's really understanding the entire manufacturing process from beginning to end. So this is all about information. And materials are scheduled more closely, reducing inventories. So again, if you don't care about inventory, if your inventory is cheap, your raw goods are cheap, you may not have to have such a complex system. But as things become more expensive and more complex, it's generally necessary to have such a system. And especially when you have very many products with very many components, individual pieces, complex assemblies, maybe sub-assemblies along the way. And you can tie this whole thing together based on your delivery times. So in summary, we've covered a very brief overview of the topics of inventory management from Chapter 12 and MRP. ERP is basically Enterprise Resource Planning, which is just an extension of material planning, which includes the broader scope of activities within the organization. So that's very briefly what we covered in this video. You should be getting ready for the second simulation at this time. But I wanted to give you this brief overview. And again, there's a lot more detail in the book. There's a lot of information available online as well. But you can go in and look at these calculations. These are the kind of things you're going to need to effectively manage your second simulation to optimize your costs, minimize your inventory while keeping the factory flow going. So without that, I guess that's about it. course, as always, if you have any questions or suggestions, let me know, and I'll see you next time.